Moving on to the next agenda item, we have special presentations. The value of active learning as seen through the Robotics Academy. Thomas Voden, PhD, Associate Professor of Mathematics, U.S. Department of Education STEM Grant Co-Director and GCC students. Ernest Hovhannisyan, Rene Khajatourians, Sung-Hoon Kim, John Paul Lionel, Marek Litomsky, Vivian Safarian, Skylar Salibian, Tamara Talverdian, and Roman Zagrabian. Vice President Murch, would you give us more details on this, please?
You may have seen in the news press a couple of weeks ago an article dealing with the Robotics Academy and this particular group of students. They were articulate, they were energetic, they provided a great deal of information, and at that time, one of the things that I could go on forever, but I'm not allowed to, is the fact that the learning experiences these students had. And instead of any of the rest of us discussing this, this is for them to discuss. And I know for a fact that they have worked very hard on coming in on Fridays to plan and to, they had a stopwatch on their speech so that they kept it within a time frame. We could all learn from some of that. But anyway, they did a wonderful job. And they will be presenting their experiences and will be more than happy to answer all of your questions, I think, when they complete their presentation.
Good evening. Thank you for having us. My name is Tom Voden. I'm an Associate Professor of Mathematics here, and I'm also a Co-Director of GCC's HSI STEM Grants. This presentation offers a snapshot into the development of GCC's Robotics Academy. With generous support from the U.S. Department of Education, what started as total grassroots student club wanting to build stuff is now part of GCC's curriculum. So the students speaking here tonight are representing a team of 9 students who had to come together in a multidisciplinary way to execute some serious engineering projects, and they were guided by their mentors, Richard Ohanian, Armin Turian, and Savada Isayan. This project and their story represents a really nice example into the promise of active and experiential education. So without further ado, I'll bring JP up to the mic and he'll start telling you the story. Thank you.
Hello everyone, my name is John Paul Lionel and I was part of the mechanical team in this capstone project, and today we're going to give you a little talk about the values in our past experiences through this past year in the project. So what is capstone? To give a general idea of it, what it is basically a multidisciplinary project that supplements academic knowledge, your theory, with practical hands-on experience, applications as well. And one of the very unique things is that it also provides intensive active learning experiences that require students to solve real-life engineering and scientific problems. And this could not have been accomplished without our unique mentor-student dynamic that we had. You know, in your traditional classroom, you have your teacher that is teaching you the subject, telling the students what to expect of the class. But we had something a little bit of a different dynamic in our project. Mentors were there just to provide guidance for us. So when we had a problem with our part or anything regarding that, we were to attack it ourselves. Where the mentors were there just to guide us around it rather than giving us a solution to it. And as Professor Voden said, we were consisted of 9 people, comprised of 3 teams: the mechanical, which I was a part of, the electrical team, and the software team. And each team had about 2 to 3 students in each team. So why capstone? In your typical community college, you have your transfer students who just want to get in, get their major prerequisites, get it done, and transfer out to your 4-year. You also have students that want to pursue career and technical education as well. And the nice thing about the capstone class is that it combines both, gives you hints of both. It provides exposure to real-world engineering, prepares one for the workforce. It also simulates a startup business. You also learn a lot of soft skills such as leadership, project management, time management, and very effective communications. And Vivian will expand on that.
Hello, my name is Vivian Safarian, and I'm going to talk to you about the transfer process. Going into community college, most students are primarily concerned with transferring in, passing their core classes, and transferring out. However, more often than not, this leads to those students overlooking the fact that their theoretical knowledge needs to be supplemented with practical applications in order for them to really succeed in the workforce of their chosen career paths. Personally, when I entered this college, my stated major was electrical engineering. However, I didn't truly understand what that meant until I took a course such as Capstone, which gave me the opportunity to really gain a hands-on experience. You may be saying that we do have lab courses, but being enrolled in lab is not enough. For example, in our physics labs, we're given manuals with predefined procedures that we simply have to follow. Making a mistake is quite simple because you can either repeat the step or go all the way back to step one and repeat it. And this process is simple because you know what your outcome is supposed to be every single time. But in Capstone, we're not given a manual. We are continuously undergoing a process of trial and error, writing and redefining our own procedures. And when you make a mistake, it's not plausible or efficient to start over on a completely new project, nor will it be efficient to do so wherever you work, no matter what your chosen career is. We have to learn to become problem solvers. We have to learn to be creative in order to ensure that in the end, we do have an outcome. We don't always know what it is, but we want to ensure that it is a working outcome. And with Capstone providing the entry point to this combination of style of learning, it really ensures that students, when they transfer in, will gain enough experience and develop the skill set that will make them succeed and prepare them for their future. And I know now that after working within the electrical team and working on the circuits to make the printer functional, that I have fully declared electrical engineering as my major and now will be transferring with a peace of mind. And now I'm going to pass it on to Rene so he can talk more about the process of after you transfer into the workforce.
Hello everyone, my name is Rene Khajatourians and today I'll be talking to you about the workforce preparation aspect of the Capstone project. Projects such as Capstone are simultaneously beneficial to both CTE and transfer students. This project familiarizes students with the skills necessary for the 21st century industrial needs. Glendale Community College already has a wonderful manufacturing technology facility, and it also offers many different courses which teach students how to use different softwares such as SolidWorks and AutoCAD to create 2D and 3D drawings and CAD models of different parts. Capstone project bridges the gap between traditional CTE instruction and transfer-oriented instructions. By going through this process, we not only learn how to utilize the softwares and tools learned in classrooms, but also how to take an idea or just a drawing that we had and make a final tangible product out of it. This is a perfect example of an active learning process. For example, a personal experience for me by going through the Capstone project was taking an idea or a drawing that I had for a particular part of the project and making sure that it met our technical requirements first. After that, I had to start by making 2D and 3D CAD model and drawing of the part, and also make sure that the part will fully function once it's machined and ready to be integrated to the larger system. Next, we had to pick the proper material for the part and purchase the material. And lastly, by the help of our manufacturing facility staff, we were able to machine the parts and have a final product ready to be assembled. This was a very helpful and important part of the Capstone project for me because it gave me a clear idea of how the real-world engineering process works and what it takes for engineers to take an idea that they have or just a drawing that they have on a piece of paper and make a final product out of it ready to be used by customers. This would not have been possible without going through the Capstone process and experiencing all by yourself. And with that, I will now pass it down to Tamara to continue the presentation.
Hi everyone, my name is Tamara Talverdian. And this is a picture of what Rene was just talking about, of us in the machine shop trying to manufacture a part. So I'll go on to talk about how the Capstone project is sort of like a startup simulation. So first things first, this aspect of the project is mainly to inspire entrepreneurial spirit within our students. As we all know, most startup companies, such as Apple, have started with just a couple of students at a university getting together and just trying something new. Such projects are scarce at community colleges, but GCC has courageously put a step forward to encourage involvement of the students, as well as remind us the possibilities that our pursuing fields can hold. A wise professor once told us that the success of a product is dictated by the market. So this reminds us that we need to not only understand technical aspects of our projects, but also understand how the economy works, financial efficiency, and just how the world works in general so that we can be successful with whatever we choose to do. If we were to get together, just the 9 of us, let's just say, and try to start our own company now or start our own project, failure would definitely not be an option because we simply would not be able to afford to make any mistakes. So thank you for that. But in the school environment, we believe it's ideal for us to do such projects because we do have a little bit of freedom to fail and try to make compromises. It also lets us learn from the mistakes that we made, which we otherwise would not have had the option to make in the first place. So in this project, we were able to, we were given the opportunity to do technical as well as non-technical tasks, such as creating a bill of materials, going over budgets like we just did, and weighing in cost efficiency of our development. So this was especially beneficial to me because although right now I'm studying mechanical engineering, I hope to someday maybe start my own company. And by participating in this capstone project, it definitely helped me attain some management skills and also to form a network. So right now we built this project with just a couple of students, but hopefully someday we'll all become colleagues and we can help each other out in the future. Now I'm going to pass it on to Ernest to give final remarks.
Hello, my name is Ernest Hovhannisyan, and I'm one of the members of the capstone team. So I want to tell you about what it is that we built. So far they've been telling you about the capstone project and what it is, but this is actually what we've done. During our time in the academy, we worked on 2 independent projects. We built a 3-dimensional printer, and we made a robotic arm. And we have a short video demonstration of what these projects are, but first I want to tell you about some details about them. So the 3D printer is basically a 24-inch cube, 24 inches on either side. And we're going to be demonstrating the x-axis motion. And the robotic arm is about the size of a human arm, so about the size of my arm, and it has 5 degrees of freedom. It can move. It's got 5 joints that it can move on. Additionally, we're going to be showing you the graphical user interface that our own software team developed to control the arm, which is very impressive. It has a 3D rendering of the arm, and it'll have 2 poses. So one pose will be for the current position, and another pose will be for the desired position. And here is the video for you, so you can see that. I promise it looks better than that. Well, here's the key thing here. Both of these projects require collaboration on 3 different teams. And we had to learn how to talk to one another about the different subsystems to make them work. So what has this project done for us? It's helped us gain very valuable skills that are not often taught in regular classes. We learn how to become effective leaders and effective communicators. We learn how to manage our time correctly and allocate tasks. And one of the wonderful things is it's created an environment where our learning has resulted in a working piece of equipment. And the magic ingredient in this entire process has been that we were allowed to do this in a robust active learning experience. And that pretty much summarizes our presentation today. This has truly been a unique experience in our educational development. We want to sincerely thank GCC, the faculty, and the board for supporting us through this journey. And we will happily accept any questions or comments you may have. Thank you.
Thank you very much for your presentation. I will entertain questions and comments from my colleagues. Ms. Ransford, go ahead.
Well, first of all, it's just delightful to hear from all of you. We were just very much enjoying your enthusiasm and your looking at your bright futures. I'm just curious, is it a class? That's what I don't quite get. It's a class and you get so many units for it? Or?
Yes.
And capstone is the name of the
cohort? Or?
I could probably chime in on that. So this, the energy behind the project started a few years ago as a club that I was the advisor of, and it was entirely student-driven. And that's some of the sort of the kernel of the idea that was written into one of the HSI STEM grants when we got the funding 3 years ago. And so the process through the early part of this grant funding period has been to take that energy and transition it into coursework. So now these students were all part of the class last year, which was largely independent study because we were still writing the course, getting CNI and board and state approval. So the capstone portion of the Robotics Academy is a two-semester sequence of courses, Engineering 298, 299. Now they're full-blown coursework. They're 3-unit courses each, 1 unit lecture, 2 units lab, kind of to try to account for the sort of balance, the open balance, as well as the guidance coming from the instructors. And so now we are curriculum, yeah.
Thank you.
Great. Mr. Aguilar.
Well, first off, congratulations to all of you. It was a great presentation. And just a quick question for all the participants. What was the greatest challenge that you guys all faced as a group? That's what just struck my mind.
I'm going to sit for that one. Maybe someone can jump in.
I think I speak for everybody when I say I'm going to answer your question in kind of a tangent. We think that the capstone has rid us of a fear of starting something that we don't know anything about. When we started the project, we did not know what a 3D printer was. We had never seen one. We had never seen it work. So we've gone through this project now, and we all believe that now, whatever project is thrown at us, we have a sort of a problem-solving way in our mind of how we're going to attack it and how we're going to solve it. And that's the biggest thing. But that was definitely the biggest fear in the beginning of, how do we do this? What is a 3D printer and how are we going to do this?
Thank you.
And Mr. Tartaglia.
I think Ms. Gabrielli was first.
Okay. Ms. Gabrielli, go ahead, please.
Thank you. Dr. Voden, congratulations and thank you for your innovative teaching style and for taking that extra step to bring something like this and make it a reality here in our college campus. And to the students, congratulations, thank you. I think, you took the opportunity to make yourselves better and to learn something that's truly going to help you, not just in college, but when you leave and you join the workforce to, for teamwork and actual real life example of solving problems and creating either processes, learning from them, or creating product. So I think you were articulate, so well prepared. I'm very proud. I encourage other faculty and maybe the college as a whole to showcase this so that other students can be motivated and know that this is available and they take advantage of it. Thank you.
Thank you for your kind comments.
And Mr. Tartaglia, we'll get to Ms.
Thank you to all of you. Capstone to me sounded like what I went through in my four-year university for my ME. This is your final project class, and it puts real-life example to work. And yes, you spent a lot of long hours, and I'm sure they were after 5, probably into midnight. But for those curious out there, because I'm a little curious, a 3D printer, you guys talked about it, but you didn't talk and tell us what it was, other than me imagining what a CAM system is, and that's generally what a 3D printer strikes me as, making something that's viable in this universe. What's a 3D printer?
I can answer that for you. So pretty much what a 3D printer is, it's the same as a regular printer, except it prints with a different material, something that's three-dimensional. So in our case, it prints with plastic. It comes in a plastic filament, and it just prints layer upon layer upon layer, which eventually builds up to having a three-dimensional object as your final product.
Like what, in the medical industry, what you would generally make thing. So it's like the CAM system, computer-aided manufacturing.
It is,
and you're making something 3D.
Yeah, the thing is, instead of usually all the other machines, you start off with a piece of block and you cut through it to get your final product. In our case, it's the opposite. we're starting with nothing and we just build upon layers to create our final product.
Interesting. Thank you. Thank you.
Sure.
Thanks. And Dr. Hakopian, please.
Yes, and Mrs. Gabrielian and I were privileged enough to go to where the 3D printers are and look at that whole program. What I would like to also say, this program, your program, was taken from News Press and printed in the Armenian California Courier and went to probably 50,000 people, and they saw it, and I worked with the publisher of this paper, because not only you, the community thinks this is very important. So more power to you, and know that many, many other people know that this is going on with you at GCC.
Okay, one more question from Mr. Tartaglia.
Congratulations to all of you. Public speaking is just below death and taxes. You did excellent.
Yes.
Thank you. And one final comment from Dr. Murch, please.
I just wanted to share with the board that Dr. Voden, with his work in Gauss, and the team, Yarnui, hiding in the background, and Kathy Durham with their work with Gateway and with AIM, one of the critical components that we made a commitment to when we applied for these grants was to institutionalize the activities that we were doing and not to limit it to cohort work and then it die after the grant is gone. So the component with Dr. Voden talking about going through the curriculum committee, he has done that and he continues to do that. In biology, for the biology research, they have also just recently, in fact, I think last month, you approved the class on bio research. We're doing the same thing in the chemistry area where students can do actual research. The same component of the active learning, the problem solving with guidance. And so these have been incorporated into our curriculum. And I think that with Gateway, they've incorporated the workshops into the Learning Center so that we don't just finish this grant or these grants and walk away, but actually the community, the students, and the faculty have been changed as a result of the work that's been done. In addition, we, if you notice, Scott has changed his spot. We asked that this be recorded so that we can present it to faculty, we can present it their presentation to others, and continue to grow the active learning that we are involved with here at this college.
Thank you very much.